Okay, all right. So first and foremost here, we were talking about the trig functions the last couple days here. Or I guess yesterday was the first day we kind of introduced it. We're doing for acute angles only. These only work for right triangles for right now. Eventually, and I think it's either the end of chapter 5 or early chapter 7, we learn how to do this for non-right triangles. But that is a lot of work. It's just a colossal amount of work that we have to do to calculate that stuff, and it's not easy. So that we'll get to that stuff eventually. It's end of chapter 5, early chapter 7 stuff. Question? Oh yeah. So I'm gonna throw it at you. You're fine with that?
Yep.
Nice. Okay. All right. Now let's go through the formula. So we did sine yesterday. That was this one. I want to do one example of this, of how do you use sine. Like, there's a couple different ways you can do it. There's 3 potential options for what you need to type. So we're going to go through each type. Now, there's 3 things you can do with sine, and just throw it over here right now.
I'll make it. She made it last time. I did make it last time.
Okay, do it.
Oh!
That
was a gun.
I did it.
Up top.
Jeez, calm it down.
Well, here's the thing. Would you rather hit me up, have me hit up there, or would you rather hit me
up there? Good call. All right. So, okay. All right. Anyway, all right. So let's work through how to do a sine function with just some random numbers plugged in. And now I'm going to do 3 problems with sine in it, and then we'll go to cosine and tangent. I'll do one of each. Okay. So this is the one we're going to spend the most time on. All right. So let's say I give you a right triangle here, and we're going to use this triangle for a couple different examples here today. So I'll just be kind of redrawing on this one, just kind of over and over and over and over today. Okay. So first of all, if I give you some numbers here, let's say that this angle up here is 35 degrees, and I want to find maybe this part over here, and I'm given this wall right here is 42 feet. So it's a really big ladder leaning up against a building, and I want to know, how far are we away from the building to make this possible? So this problem is perfect for a sine function. Now, I want to talk about why it's sine and how do I know right away. It's because of the labeling situation. Before I even just guess at a trig function, sine, cosine, tangent, I just label my picture. That's how I know it. What I mean by label, I find where my angle sits. My angle is right here. This is the angle that I'm using. I'm going to look at the labels from that angle that I'm using. So if you have a couple different angles, just pick one and label the picture from that angle. So this wall over here is called the opposite. It is the opposite side from your angle. And then this would be the adjacent, which in my case, I'm not using the adjacent wall. There's nothing over there, bless you. So I'm not using the adjacent wall. I'm going to cross that out. I'm not using it at all. We're not using it. Then the remaining wall that we have here is the hypotenuse. The hypotenuse is the only wall that doesn't touch the right angle. So hypotenuse should be the easiest wall to label. It's the only wall that doesn't touch 90. Okay, does that make sense for how I labeled it on this picture? Yeah. And I'll do a different picture here in a minute. I just wanted to show you this. So by looking at this, I'm using opposite, because that's the wall I need to find. I'm using hypotenuse, because that's a number sitting there, and I'm using my angle. So think about like the little acronym we talked about yesterday, Sohcahtoa, right? Using this little acronym, it looks like I'm using this one right here. I'm using the sine function because I'm using opposite and hypotenuse. The adjacent was not used. There was no variable. There was no number. I don't use it. That's how I think of it. I mean, I look at the back 2 letters and figure out which ones are in my picture that I'm using. So that's how I can kind of tell. So you can eliminate the ones that don't use the adjacents. So that's another way to think of it. So now the sine function, if I write this down, sine of your angle is the opposite over hypotenuse. This is the formula that we wrote down on the board yesterday. Now, how I know the formula. The little acronym Sohcahtoa tells me how to write it. The second letter goes on the top. The third letter in each of those acronyms goes on the bottom. So in my case, the hypotenuse, the H went on the bottom. Does everyone feel comfortable with the setup? Okay, so now I'm going to plug in my numbers or variables in. it should be 3 locations. 2 of them should have numbers. 1 should not. So in my case, I do have my angle, so I have my theta. So in my case, I have sine of my 35 degrees. So I do have the angle. The opposite is the x, so that's the one item that I'm missing. And then the hypotenuse is the 42. And you can put the label on it if you want, doesn't matter. Okay, do you notice that only one location is missing a number?
Yeah.
Okay, and we'll do another one of these. So we're going to do 2 more that have sine in it, just so you get some practice with it. Now, does everyone have their calculator? Does anyone need to borrow one? Because I know some people came in late. Anyone need to borrow a calculator? Okay, all right, so big thing before we start. Does your calculator on the screen say DEG, really, really fine print, or like a little lowercase d? In fact, I'm gonna kind of zoom in just so you can see this. So it doesn't look like anyone's zooming today. So, all right, let me zoom in on mine just so you can see this. All right. So if I zoom in really, really close, you can see the little DEG on the screen. It's right there.
Where? Oh, I see your.
If it can focus.
Almost bottom right corner. There she is.
There it is. Now, the other things it could say rad. It could say GED. This is radians. So if I was in radian mode with radian angles, I could have that. If I was in gradients, that's more of a college stats kind of a course thing. We're not going to use that. But they would say different words if I was in different modes. Like if it said radians, it would say rad on the screen. I want to be in degree mode because we're using degrees.
Rad, dude.
Okay. All right. All right. So let's go back and let's check out our problem here. So, okay. So to solve this thing out. Since the x is on the top of your fraction, and I want to get the x by itself, this is what you do when the x is on the top. You multiply this number across, because that's the inverse operation. That's how you solve for x, to get the x by itself. You multiply the 42 across, and you're going to multiply it on the sine of 35. Now, everyone's calculator can be different. So this is the part that I want you to get used to today, is how do you type this in your calculator. So I'll show you how to type it in this one, and then we'll look at the answers. Okay, so to type this in. So to type this in your calculator, I'm going to type in that 42. I'm going to type in the sine. Then I type in the 35, and I close the parenthesis. Hopefully you guys can see that. And then hit enter. You can put the multiplication sign between the 42 and the sine. It should be 24. That's roughly, and if you want to go a couple decimal places, 42.09. Doesn't matter. Okay. Now, what is the label going to be? Feet. So, this should be in feet. So, this will end up being 24.09 feet. That's how far away we are from the bottom. That's if your x is on the top. Now this strategy works for any of the trig functions. So cosine, tangent, if the x is on the top, you multiply the bottom number across. And you just type it in exactly how you see it. Did anyone not get the 24 that needs to know how to type it in their calculator? It looks like, it appears that everyone in here, except for maybe Hassler, has the same type of calculator. So I think on yours, you have to type in the sine of 35 first, and then take it times 42, I think.
I don't know, I did how I thought I was going to do it.
And it worked?
It worked, yeah.
Okay, all right. So no worries then. I'm just worried about the later ones, because yours will be different. All right. Anyone else not get that? Now, cell phones, if you have a cell phone at home, because I know some people, you're a realist, you have a cell phone at home, you're using a cell phone. The cell phone is typed in differently, and some cell phones are in radian mode, not degree mode, and there's no way to change it. You might have to go in like the settings of the calculator. Like if you have an Android, it's pretty easy. Hit the menu button, you go in and you change the setting. On an iPhone, I think it's automatically in degree mode now. It used to be in radians, but they've changed it to degrees over by default. And there's no way to change that on an iPhone. So it has to be in degree mode. So are we good with this? Okay, let's do another example. I'm gonna stick with the sine function still. Okay, so here we go. The next one. So right triangle again. I'm going to draw triangles in different ways here in a little bit. My next picture will be drawn differently. I'm going to put an angle up there. So let's go with 22 degrees. I'm going to put this as 10 meters, and I want this number now. And I want the hypotenuse. So now let's do the labeling situation. Again, I've said that for right now I'm just doing sine function over in just different ways, just so you can see the different ways you can see the same function. So the labeling situation. This is my angle, obviously, so duh, that's theta. This is my opposite wall in this case. It is opposite where my angle sits. The opposite wall can move depending on where your angle sits. So across the picture is opposite. Right here is the adjacent wall. The opposite and adjacent should touch the 90. It looks like in this case, I am not using the adjacent wall again. It's not being used. So I don't need it. There's no variable there. There's no number there. I'm not using it. And then obviously the last wall here is the hypotenuse. And that's actually the wall we're trying to find. So now, looking at my little acronym, Sohcahtoa, knowing which trig function to pick, you have to look at the labels you're using. I'm obviously not using the adjacent. So if I'm not using adjacent, these are the ones that go away. They have A's in them for adjacent, so I'm not using them. So I'm using the sine function again. And I already kind of warned you that I was going to use the same function for the first couple. Just so you get used to, like, why am I using this one each time? Because the labels tell me that. Opposite and hypotenuse. And those are the ones that have the numbers or variables in it. Now, plugging this in, this is sine of my angle is equal to the opposite over the hypotenuse. So if you need that formula, here it is one more time. I'll keep writing these down just so you get used to it. Again, the little acronym tells you how to write it, right? It's telling you O over A, that type of thing. Now, on this problem, do we see how this problem is different than the last one? X is on the bottom. So since the x is on the bottom, we're going to have to get rid of the x. So whatever the bottom is, you're going to multiply it across. So I'm going to multiply this x across to the other side. And so it comes over here. Now this isn't my final answer. This is just I'm getting the x off the bottom of the fraction. And then the last step is to divide by the sine of 22. So take this number to the other side and divide by it. So that way I get the x by itself. And no, you're not doing anything with the 10. The 10 is just staying where it's at. 10 meters divided by sine of 22. Now, on a calculator, my calculators, this is really easy. Type in exactly how you see it. 10 divided by sine 22, close parenthesis, hit enter, boom. Hassler's, he has to do a little more work. He has to figure out how to type in the sine of 22, write the decimal down, and then take 10 divided by whatever that decimal is. So you have a little bit of extra work you have to do on yours. That's not a menu diagram where you can just see it. So again, I'm going to go back to my calculator screen. So go back to my calculator here. I'm going to type in 10 divided by the sine of 22 and close the parenthesis and hit enter, and it looks like it's 26.69. If you want to go a couple more decimal places, that's fine. More decimal places, the better. But I'll just go 2 decimal places for today. So 26.69. All right, so 26.69, and that's in meters. Now, the reason I'm bringing these up, you're thinking, Ward, you just keep doing the same trig function. They're being solved differently because of where the variable lands. That's why I'm trying to show you, like, the strategy I'm showing you here work for any of the trig functions. Works for sine, works for cosine, works for tangent. Is you just check where the variable is and you solve them the same way. You just use the different buttons, though. Okay, we're good with this so far. Okay, the last one, and I'm using sine again, the last one where now the angle will be missing. So, last one with sine, and then we'll just talk about the others. So, triangle again. Actually, let's draw a different triangle here. Let's draw it like a different way. Kind of just kind of throw it in just oriented a different way. All right. So in this case, it's still a right triangle. These only work for right. I'm going to be missing an angle. So the angle I'm going to be missing this angle right here. This is the variable. That's the angle I want to find. Give me any two numbers we want.
74 and 92.
Okay, 74. And let's go with millimeters and 92 millimeters. Is that what you said?
Yep.
Okay, let's go with those numbers. Okay, and we're gonna find the angle now. So labeling the picture, I still go with my label to figure out if I'm still using sine. I know I am, but to see the labels, this makes the big difference. So this is my angle, obviously. What would this wall be called? Opposites, directly across. The wall over here, this wall? Adjacent, right? And we're not even using the adjacent. This is just the adjacent side. It's touching the 90. We're not using it. We can cross that one out. We're not going to use it. There's no variable there. There's no number there. We're not using it. And then obviously the hypotenuse is here. So I always like to label, and I do this for every picture, no joke. I do this every single time. That way it tells me which trig function to pick. It's not random. It's not you're always using sine. You have to label it, and the labels tell you which one to pick. So it's telling you which buttons because of the labeling situation. So when I go back to Sohcahtoa, the one that I'm using here is opposite and hypotenuse because the adjacents were all thrown out. The ones with A's in them because I didn't use adjacent in my picture. So that's why I'm throwing the ones with A's in it. So I'm using the sine function again. So that's the sine of your angle is opposite over hypotenuse. One more time. Again, the acronym tells me how to write that. That's why I keep writing Sohcahtoa on everything. So plugging my numbers in, I have the sine of x degrees is equal to the opposite over the adjacent, or over the hypotenuse, sorry, over the hypotenuse. The millimeters labels cancel out using that idea of a dimensional analysis, right? So the millimeters labels cancel. And now to solve this, we're missing the angle. So this is a new button on your calculator. It's right next to the sine key. You'll see it. It's signed a little -1. So what we have to do is we have to do an inverse function. It's called an arc sine or an inverse sine, however you want to say it. We're taking the sine function of the other side. We're going to leave the x where it sits, and we're going to do the arc sine, which is written like this on your calculator screen. It's a little sign to the -1 key. It's also known in other textbooks as arc sine. It's written like this in other textbooks, especially your calc book that you'll see next year. They mean the same thing. And then in there you type in the 74 divided by 92. And it will give you your decimal. It will give you the angle. That's what that button is solely used for. It's just to find angles. That's the only time you ever use that button. Now to get that on your calculator screen, let's bring it up here. So to get this popped up, you have to hit the little second key. So it has a little second key and it shows second on the screen there if you can see that. And then you're going to hit the little sine button so it gives you the little sine -1. So it's in the blue, so you have to hit the second key first. Then you type in the 74 divided by 92, hit enter, and it tells me my angle should be about 53 degrees, 53.5. So, okay, is there any questions with that? How I got that, you hit this shift and then hit, or second key, whatever you want to call it, and the sine key. And it gives you your angle. So, what is this, 53.5? 53.55? 547, blah, blah, blah. And it's your angle. Okay, I think we've done enough sine functions. Let's just talk about one of the others and I'll stop here. This will be my last example of the day. We'll just do one of the others. And I'll just kind of pick at random which one, so we'll get away from the sine. And we can do for any of these other trig functions, cosine or tangent, it could be any of those three strategies I just told you. The variable could be on the top of the fraction, could be on the bottom of the fraction, or maybe you're finding the angle, and you have to do them all the same way. But you have to use that trig function key when you do it. So let's give you a triangle here. Let's say my triangle is drawn like this. So it is a right triangle. Let's say that my angle is 70 degrees here. I'm going to be missing this wall, and this is 14, and let's go centimeters. Now again, we have to label the picture. The pictures are all going to be drawn randomly. So to go from here, how do we solve it? What do we do? We have to label. So what are my labels going to be? Like, what is the side with the X called? Opposite, right? It's across from your angle, so that's the opposite wall. Okay, good. And what is this wall called with the 14? Adjacent. So if I go to my Sohcahtoa part, again, this is my angle here. So if I go to Sohcahtoa, it will tell me which formula that I'm picking. Because it looks like on this particular problem, I am not using the hypotenuse wall. The hypotenuse is the only wall that I'm not using. It wasn't labeled, there was no variable there, there was nothing. So I'm not using it. So it looks like on this particular problem, I'm using tangent. I'm using O and A, because the hypotenuses were all thrown out. So this is tangent of your angle. So again, it's tangent of your angle is opposite over adjacent. So I'm going to plug in my opposite wall. My opposite wall is X. My adjacent wall goes on the bottom. That's the 14 centimeters. And so I have my setup. It looks like in that problem there's only one variable, so we're good. How do we solve this? What do you remember?
You multiply the 14 across.
Yeah, you got to multiply the 14 across. Since the X is on the top, you multiply it across. So 14 times the tangent of 70. If you type this in your calculator, 14 tangent 70, and you actually type in 14 times tangent of 70, close the parenthesis, we're going to get 38.46 roughly. And what's the label? Centimeters. Now, the only difference this problem could have, maybe they put the numbers in different spots, so you have to do maybe some other items. If your problem, let's say your problem on your Google form has an extra letter on the problem. Let's say that maybe on your problem there's the letter Y up here. They throw a second letter in there. Just solve one letter at a time. Just do one first, solve it, then go after the next letter and solve that one. So I would solve X this exact same way. And if I wanted to find Y, I can do whatever trig function I want to find Y. I just use my labels. So I found X. X turned out to be 38.46. I can do anything I want to solve for Y. Maybe I want to use the adjacent wall to find the hypotenuse. So I could use cosine. Cosine of my angle is the adjacent over the hypotenuse. And I could go ahead and solve that one out. As long as there's only one variable in your formula, you can solve it. I could have used any trig function there. I could have used tangent or to solve sine to solve for the y, because I knew what x was. X was a 38. I can go label that back up there. Okay, does that make sense what we're doing there?
Yeah.
Okay, Google question of the day went live. It's one question. Tomorrow, expect another Google question of the day. Expect another one of these. We'll practice this more tomorrow. So. Yep, and we are done for the day, so.